you, Arlen. I want to say thank you to all of you people that came out on such a warm day. Okay. Can you hear me now? Okay. We'll get on this quickly so that you can move on. Mr. Cahoon is from North Adams. He belongs to the Historical Society over there as well. Are you president?
I am the president.
He's the president. So he's gotten a lot of good information here about the freight and passenger activity in the past. So I'm just going to turn it over to you now. You know more about this than I do. They don't want to hear me.
Well, I'm pleased to be here this afternoon. It's one of the first times I've been out since a little misfortune we had a while ago. I'll explain that a little bit later. As I said, I'm president of the North Adams Historical Society, and up until March we were doing business as the North Adams Museum of History and Science. Fortunately, we were operating from the hotel in North Adams, and it was sold. The new owners did not want us there anymore, so presently our collection is in storage, and we're hoping some benefactor comes along with the proper real estate that we can move in and open up again. And I'll tell you a little bit more about what we have that will become obvious during the show. The Hoosac Tunnel. It's a very important engineering achievement. And engineering achievements are kind of obscure because they're very technical. So what's so important about this tunnel? So when they built it, it was the first time anyone had ever tried to build a tunnel of that length. It was going to be 4 3/4 miles long. Up to that point, 1,000 feet was a long tunnel. This one now they're measuring in miles. They came up with the idea first about 1825 and did a survey. And then they realized the size of the mountain was no way. And the idea lay dormant for about another 25 years. The incentive came from a man named Elva Crocker, who was a paper manufacturer in the town of Fitchburg, Massachusetts, which is 100 miles east of here. At the time they were building a railroad we now know as the Boston and Albany. It about parallels the route of the Mass Turnpike. So Elva was going to have to ship his goods all the way to Boston, all the way back across the length of Massachusetts and into the Albany area. He was trying to make a connection then to the Erie Canal, which had just opened. So that's the idea of the magnitude of what was going on here. So the one barrier was the mountain. As I said, no one had ever tried one that long before. They did not have the equipment to do it at the time. So to start a job without equipment was a challenge in itself. And how they did it at the time, I'll get a few visual aids here. They started with a hammer. Of course, theirs would have had a handle about 4 feet long, and one of these, which is called a star drill, and it too would have been about 4 feet long. And they would have one man holding it and the other one swinging the hammer. And then when they got a hole deep enough, we put gunpowder in it, set off an explosion, and loosened some rock. It was quite inefficient. It went on from there. That's how it all began. You come up and look at these ladies and see what it was like. When they got done, there were many inventions. Now you say that historically there are 7 categories because you would track the inventions by patents made, and on some of the different devices they kept reworking them and repatenting them to keep the rights to make them. So there was a lot of discovery that happened here. And to back up this story, and I too went to see this myself when I heard about it. At the Smithsonian Institution in Washington, D.C., there is a segment, and it's about as big as this room, on hard rock mining. And a lot of the displays are about the early days when they would build a fire against a rock and then dash it with cold water, or hammer and chisel like this, all the crude methods that were done. In order to bring it into the modern world with all the equipment that we have today, they had but one example, the Hoosac Tunnel. You figured it all out there. So that's what makes it historic. Unfortunately, the railroad is very careful of their property, and it's hazardous to be around, especially the western end, and it's off the beaten path, so it can't be seen from anywhere on the highways going by. It's a quarter of a mile down a very narrow path, and no one can really visit there legally. We do have many pictures, and you'll see them in the show. We've come by a lot of these over the years. The eastern end is beside the road, and there's sort of a parking lot there where the railroad keeps some of its equipment. That one draws a lot of visitors. We've even seen rail enthusiasts come and bring their travel trailers and camp overnight just to listen to the train go by. So it is known, you can see it in one portion. Well, back to Mr. Crocker, he was able to petition the state legislature to charter a railroad from Fitchburg, eventually to Troy, New York. He got his railroad, and then they went looking for contractors to build the tunnel. And it took them 25 years to get it done and get it open. I mean, poor Albert Crocker, he did get to see it. He had to walk through it, and they eventually had a hole through the mountain. But he never got to ride a train through it. He passed away before they actually started service. But that is our claim to fame in North Adams. We have this tunnel. And I'll give you some more about it. They have a show here, and I'll explain some of the things as they go along, and we'll have some pictures. It'd be more interesting than just having me talk at it. For you folks, if you kind of find another chair in there, you don't have to be here to get this going. Computers. This thing sometimes gets slow, it does its own thing. There we go. That wasn't supposed to happen. That I can get when it comes up. It's still in the beginning. What I'm looking for now is the slideshow. I know there's one place. So there's a,
Yeah, right there. It's right just above the cursor.
about, we're looking at this one. There's also an icon down here that's supposed to get it. Yes, way over. That's the long way to get to it, but it works. And I started with the North Adams City seal. It is our claim to fame. And there on the seal is the motto, we hold the Western Gateway. And there's a drawing of the tunnel entrance. No, we just go on. Here's a picture of it. And Yeah, there's two sets of tracks, so that tells me it's after the year 1880, because that's when the two tracks were first installed, and they have the door on it. No other features there at that time, so it could be as early as 1900 that this was taken. Now we'll go to one that I took, and this was when the train came on the centennial observance of the completion of the tunnel. And your vice president who just said about the Mass Bay Railways, was that?
Mass Bay Railroad, enthusiast, yeah.
The enthusiast.
The Mass Bay Railroad.
The man who was the key in Boston. Interesting there, this one was used for commuter rail service in the Boston area. And the giveaway there is, you see those steel rods on the windshield, also known as ghetto grates. Now, when they began building the tunnel, they got the idea of using a machine to bore a hole through. And what it looked like was the device that you see there on the table, and we'll go get it, hold it up for you. You understand in the world of tool making, this thing is called a cravat, or a hole saw. There's some teeth around the edge and makes a 3-inch hole. Well, they built a machine, steam powered, that made a 24-foot hole. They tried it out there, and on the left of that picture, you see a portion of the bore that they started out. They went about 15 feet into the mountain, and the machine broke down. And it was threaded so far into the wall there, it stayed there for many years until they scrapped it, I assume about the time of World War I. At the time, there was no such thing as an acetylene torch. They had no way to get it out of there. So they went over a little ways and started another bore. And that's how they were doing what we have under the chisel. Now, there is a model of the boring machine. And this was made by a friend of mine, Jerry Kelly, who was also a rail enthusiast, and he came to us for information studying how they surveyed the tunnel. He wanted to know how they drilled a hole 5 miles through the mountain and came out with, this is amazing, 9/16 of an inch accuracy in the heading. And you start digging a hole from both sides of a mountain and you meet within 9/16 of an inch of your target. That was an amazing surveying feat. And if anyone wants to write this down, Jerry Kelly has Facebook page, Hoosac Tunnel, Then and Now, and another amazing collection of pictures on the subject. This is one of our artifacts. It's a cutaway diagram of the Hoosac Mountain. And you can see there some of the features, and there will be other photos in the show here that will show the details close up. What's interesting about this is it has the signature of Mr. Granger, the chief engineer on the project. The Hoosac Mountain has 2 peaks, which you see there. This drawing is made in 2 different scales. The length and the height are not to the same scale. The height of it is about 8 times what the length is. Because if this were to be drawn totally to scale, the length of it would be more than the width of this room. One of the HO railroad clubs in the area wanted to make a complete scale cutaway of the mountain in order to show what they did, and gave up on the idea because if they were to do this in HO scale, which is, cars are about 2.5 inches high, the mountain peaks would be 9 feet tall, and the length of it, the portals, would be almost on the goalpost lines of the football field. And it gives an idea of the proportions of what they did. This is one of the things we have in our collection. It's called Hadley map because Mr. Hadley, the city's chief engineer at the time, in the 1930s, took the U.S. Geological Survey topographic map, cut out the layers according to the contour lines in that map and assembled it. So you have a 3D model of the terrain. And in the center of that, there's a double dotted line, and you can see the Twin Peaks there. That shows the path of the Hoosac Tunnel. And the rail lines are there by the tick mark lines. And you have to know a little bit more about the geography of North Adams to fully understand it. Over on the left-hand side, the road goes slightly downward toward the edge of the picture and then back. That represents the Mohawk Trail and the hairpin turn, if any of you are familiar with that. And this one, you'll get it. That's taken 90 degrees away. Then there is the same perspective as the drawing was taken. You can see the path of the tunnel over the mountain. So from one edge of that picture to the other represents 5 miles. There's the closer up portion of the western peak. And again, drawing up there at the west portal. On the left-hand end, there's a portion of the mountain that seems to be not sloping very much, and then there's a shaft there. It's called West Shaft. It's 300 feet deep. And why it's there is they were having trouble with a permeated layer of soil in the west end that was percolating with water all the time, and they had to actually use soft rock tunneling technique for that first part of the tunnel. So what they did is made a few boreholes along the line, and when they made that one, they got the solid rock at the level that the track was going to be, and they worked eastward from there, doing the hard rock mining technique. And it shows how they still had to build brick arching in there, because there was a lot of loose material, even though they got to mostly hard rock there. At the right-hand edge, there was the other feature of this tunnel that's unusual, the central shaft. There were some that thought they could make this project go faster by getting in the middle, drilling down to the level of the track, and working outward both ways from the bottom of the shaft. There were those who were working with the Albany Railroad, the one that I mentioned before, the parallel to Mass Pike, who did not want this project completed because it would be competition. And they thought by adding the shaft would slow it down. And it certainly did. That shaft was to be 1,028 feet deep, or you could park the Empire State Building beside it with the same dimension height-wise. So that was additional work before they could even begin building a tunnel in the bottom. In the end, it was worthwhile because they did get some of the work done from in there, and it's ever since provided ventilation for the tunnel. You see some text there just to the left of the shaft over the word Hoosac. That is where they made the final meeting point that opened pathway all through the mountain. There's another one on the eastern end that happened a little bit earlier, and was when they reached about halfway. And we'll see some close-ups of that shortly. Now there's the other side, and the point of the meeting there is over the word tunnel, and see that arch text. We'll get a closer look at it. And there you can read Mr. Granger's signature up at the top there, next to the word mountain. And there's the drawing of the eastern portal. And that gives the width and height of the tunnel, a section looking through it. There's another thing at the west end, and you can see the track there, and below it there's a square opening. That's a drain that they built in when it was double track. When the railroad cars got bigger and they needed to put one track in and center it again, that became a problem for them because they would then have to dig up all of the drainage for that half of the tunnel in order to have it working on a single track. And it's yet to be done because now when they want more plate, they go off the top instead. And again, a closer up with the drawing of the west portal on that with the grip. There's the central shaft and the east side. That's the point right on that. There's 1,127 feet in the tunnel from the east end. And then at the bottom there's the 25,081 feet, the whole total length of the tunnel. And there's where the final opening came, had the hole all the way through the mountain. And the date, 27 November 1873. 10,138 feet from the west end. And again, a close-up of the portion in Granger's signature. Well, put this in to explain something. The first contractor, his name was Herman Hawk. He was the one originally hired to start the tunnel. He was trying to be very conservative because he wasn't sure about would he make the heading if he followed a straight line right through the mountain. The ideal would be this. However, this could be possible if you made an error in placement of the heading. And he didn't want that to happen. So he did this. With the next frame here. He moved the west portal, and we think about 40 feet south of where the present day portal is, and made it at a slightly different heading, knowing that he would meet the other one somewhere in the middle of the mountain, and it only take a little gentle curve to get everybody together. Now, he had the misfortune of not doing his finances on this thing very well, and he had trouble getting Alva Crocker's money from the state legislature on time, and went bankrupt before he got very much work done on the tunnel. Then the state took over, and they got into their own surveyors and their own engineering team, and well, that's a photo of Hawk's original portal. And he had only made it for one train, one track wide. Later on, they enlarged it. So. And Carl Waderkin was the surveyor, and his main achievement was getting that central shaft to go straight down the mountain. And then when he got to the bottom of it, at the level where the track was going to be, he had to draw a line at the bottom of the shaft that would meet both the east and the west heading coming in. It's a three-dimensional problem to show it. It actually takes a model to demonstrate what he did to make that happen. And we've yet to actually build one because it's kind of complicated. But that's when they got done with the measuring, they were off 9/16 of an inch. Because the new engineers on the project went back to the original plan and put both headings, well, the reciprocal, the same heading, and aimed directly at the center point. Now, this is where then they started the new portal at the west end. They moved it further north to line it up head on with the one coming the other way. This is friend Jerry Kelly's model of how that might have looked when they were doing the construction. And this is an actual picture of that. And what happened there is they picked a spot for the new west portal. And they were going to have to make a cut. And there's a cut to be completed on the side there. They actually had to dig out the hillside to bring the train to the portal of the tunnel. And that picture that you just saw was them digging down to grade level when they began the portal there, and they didn't open that cut until after the tunnel was open. Now, Hawk's original tunnel is, as I said before, a little bit south beside it. What they did is made an opening from there into that pit where they dug to make the present-day West Portal. And they used it to haul the spoil out of the tunnel and back toward North Adams and deposit it. When it was all done, somehow that got covered over. And about 5 years ago, a good friend walked his dog over there, and there was a pathway up the side of the railroad cut, about 40 feet away from the tunnel. And a pair of ruts there were Jeeps and other off-road vehicles had gone up and down beside it. And he said it was washing out there, and he was wondering how long the road was going to stay there. A couple weeks later, I went up there, and behold, it had caved in, and I was standing there looking at this, down into Herman Hawk's original tunnel, and it hadn't been seen in 140 years. Now, this picture was taken standing in the portal at West End. And where that arrow was pointing into the woods, there's a hole between some of the rocks. It's just big enough to crawl into and gets into that portion of the tunnel. And about 300 feet down, further down the track where it goes around the bend, you can get out now where that washout took place. And there's a view of it where the road used to be. Now, up on the mountain, we'll see some other pictures of it later. There were 5 of these towers built, one on each of the eastern and western peaks of the mountain. One on the peak opposite the valley over in North Adams on Notch Road. And there's a place on the top of Mountain Road across the Deerfield River from East Portal where just 4 huge nails driven into the bedrock. And if you put a surveyor's instrument at each one of those locations, you sight the line with the root of the tunnel. And it's how they kept it alive. Here is the remains of the tower on Natural. And of course nowadays the trees have grown up. I stood on this spot years ago when foliage isn't on the trees, and you can see the top of Hoosac Mountain. And there's a power line that goes up right over the root of the tunnel. And you can see it lines up with this. You know, there's actually a square building, and there's 4 archways in it, and all points to the compasses. It lines up with the tunnel. Here's another picture of it in an angles, and you see how all 4 of these made a place to sight from. And they set up their surveying instruments. This is still in place, but they're going to go away. This is the one on Spruce Mountain, or on the western ridge. And you can see a square pile of rock in the middle. That's one corner of the tower that used to be there. And it surrounded that one pole. You see 2 poles there, and there's a crossbeam, and that's one of the pair of towers that make the power line going all the way over the mountain from the central shaft down into North Adams. Still visible from the road when you drive up the valley in North Adams. This one you see has an arch. This is the one on the eastern ridge. And it's right next to the power lines that go over the mountain just east of Whitcomb Summit on the Mohawk Trail. Another view of the same. And some of the iron rods that are there that were part of the structure, they put the platform on this to set up their surveying instruments. And there's myself, and Gary Kelly was the photographer in this picture. And if you see just to my right, there's one of those nails sticking up beside me. There's 3 others there that are sort of obscure. But that's the point where they look back across the valley. And you see a notch in the mountain there, all above my head, that it's the path of the tunnel up through the trees. And the east portal is in that darkened area just above the first row of trees there in the foliage. That's again taken from the same place, and that's what we call the Great Bend on the Deerfield River, which is on the lower left. Above the river, you can see the road, it's the white corridor. And the portal of the tunnel is in that shaded area, a little bit higher and to the left. And if you look very carefully, you can see it looks like a power line is moved several places across the top of the mountain. Oh, we've got to get a little closer to it. There we go. You know, you see the pathway of the tunnel there and the groove cut through the trees. There's one that starts beside the portal going up through that shaded area. In the next segment, there's one slightly visible there, and then one a little more prominent next to the last portion of the mountain. Yeah. Oh. I forgot that he's there. Oh, there it is. Okay, this right here is the Deerfield River. Microphone too. Yeah. Trying things with both hands, it's getting a little confusing. This is the road, and it goes down up to Reedsboro. There's the pathway cut through the trees where the power line went. You see them now. And the east portal is right in that area. Oh, that's sort of shaky. That's hard to do. This was the central shaft. that portion of the stonework was put in right after it was dug down to bedrock. It was before any of the buildings were built for the bucket that they ran up and down to get the workers in there to dig it. And from there they went down 1,000 feet. This was, again, you see that same stone block arrangement. And this was a building built above the shaft to house fans to ventilate it. And over on, once you get the right hand side of the figure here, that's all the smoke coming out of the shaft that was made by the trains going through. Today, it looks like that. This is the round part of the building. Yeah, there's the wall. It's part of that circular containment. And on each one of these, inside the wall of the building, there's a huge fan. And then at the end of those two black tubes, there are doors on it that swing by gravity that keeps them, the tubes closed when there's no fan being used. But when the train goes through, they turn them on. Those doors swing open and all the smoke comes out of there. You know, it gets quite heavy up there when it happens. There's a view of the building from the side, and it's just over the edge of the chain link fence. And each of these, it's a pair of doors that hinges down the middle. And they're V-shaped, so the closest edge to you there swings open. You fall back against each other. Down on the bend of the Deerfield River is this building, no longer standing, just the foundation. And it housed air compressors that they used to drive the compressed air drills later on when we made that innovation to make the drilling of the tunnel go faster. And again, it's another one of those pictures of the great bend on the Deerfield River looking downriver toward Charlemont. The building that you see in the lower left also had a pole on the top of it that was survey marking. And you can just see at the edge of the picture the corner of the compressor building. And this was the first trestle to be built across the Deerfield. And the building with the pole on the top for surveying shows there. And right behind it, there's a railroad crossing there today with the red flashing lights and cross arms when the train comes back. And here's one during the construction period, some miners, a portion of the Burley rock drill. Charles Burley was the engineer who, he didn't invent it in the first place. He found someone who had patented the supposed rock drill. It didn't work very well. And he bought the patent, and then he went to work on it. And he produced at least 5 different versions and patented all of them as he went along. And eventually got one that was successful. And they said they could run one for about 3 weeks at a time before it broke down. They had to do repairs on it and keep going. And when the Hoosac Tunnel got done, he was selling them for mining operations in other parts of the country. I've got this one labeled as spring of 1911. We chose that date for a particular reason. The picture of a train here at West Portal. And there are some doors on the tunnel there. They use wooden doors to keep the prevailing west wind from making huge icicles just inside the portal. There's no electric wiring in this yet. In the year 1911, later in the spring, they put overhead wiring and then bought some electric power locomotives to pull the steam trains through because the smoke and gas in that tunnel was getting so that it was almost uninhabitable. At the time, the records show that there were about 90 trains a day using the tunnel. So the traffic was such that if you stood by the station in North Adams, every 15 minutes you had a chance to see the train go by. Here is a picture taken from the air. And I'm forgetting, here's the path of the track, and that's the west portal. This, if you've been to North Adams, is St. Joseph's Cemetery. And this, the west wire here for the westbound train and one over here for the eastbound train. You'll see they're all double insulated from the top of the ceiling and the insulators for the wires there. The power for that was provided by a power plant in the island section of Adams, and they were energized to 11,000 volts. So shortly after this picture was taken, this became a dangerous place. Now I go into the era of the diesel in the 1940s. And this locomotive, and from the double track still being there and some of the features, we think it was about 1950. And for the rail